Audio Jungle. Audio Jungle.
Right. Superimposition of the flow. Superimposition. Okay, it's a superimposition of the flow or superimposed flow. You can say superimposed. If you superimpose the flow, then various types of the flow will be there. Few important I will tell you. Few important flow like source and sink pair. Okay, source and sink pair. This is the one kind of the superimposed flow. Second, doublet flow. This is the another. Third one is nothing but Rankine half body. Okay, then Rankine half body flow, then Rankine full body. Okay, flow. These are the flow, no? These all are the flow. The next one is cylinder flow or some generally called circular flow or flow over the cylinder. Okay, any name you can give. Okay, that is the last one. In that cylindrical flow also, two types of the cylindrical flow we have. That is cylindrical flow without rotation and with rotation. So I can mention you here that cylindrical flow only. Okay, it is automatically self understood. Cylindrical flow, that means it's a circular kind of flow. Okay, circular kind of flow means circle is there. Circle will be formed. Obviously it is the imaginary circle, but yes, some kind of the circle will be formed, and over that flow will be possible, called flow over the cylinder, because physically we do not have any cylinder. I told you it's like image. You have to check that flow will form one cylindrical shape. So you can say it's now flow over a circular cylinder. Okay, flow over circular cylinder. Flow over circular cylinder again will be divided in two parts, which is very important. What is that? It's a rotating cylinder. Okay, it's a rotating cylinder and non-rotating cylinder. Both are possible, a rotating cylinder and non-rotating cylinder. Okay, non-rotating cylinder and rotating cylinder. All right, these all type of the flow we have to discuss one by one, and remember these are very important. These are important. All type of flow are very much important for gate AE as well as gate XE. From gate XE, if you check question paper XE gate question paper, then many questions you will get from this particular topic. Okay, superimposed flow, or till now whatever I have taught, like uniform flow and source and sink flow and vertex flow, all are very very important for gate XE as well as gate AE. Okay, now we are superimposing the flow. So superimposing is one basically a method where more than one flow will be flowing, and mathematically we have to make one model. We will combine both flow, and mathematically will get one model, and based on that we have to draw the flow pattern as well, and then we'll see like whatever the possible calculation, we'll have to calculate that value. Okay, like if it is cylinder, non-rotating cylinder or rotating cylinder, so for that obviously if it is cylinder, then you will find radius. Now for doublet flow, you check the strength. For Rankine half body, Rankine full body, you will see the even what is the stagnation point, what is the tangential velocity. All those things we have to check one by one. So coming to the first one, that is source and sink pair. Okay, source and sink pair, that is first one. Source and sink pair. Right. What will happen if there is one source, something like this? If this is the source now, so obviously for this particular source, flow will be coming out. You know that definition of the source already we have seen. This is what source, where the flow is what coming out from one particular point. That point will be considered as a source. So flow is what coming out something like, see, the flow is what coming out something like this. This is what source. This is what source. Right. Now somewhere here we have a sink. This is what sink. Flow will be coming towards this point, hence it will be the sink. So flow coming towards this point, and this point will be considered as or called as sink. See something like this. Right. This is what sink. Sink. And we can say in between, suppose this from this basically a point, okay, which is nothing but O. This is the point which is nothing but O, point O, right? From the point O, the location of the sink is nothing but A. Okay, and similarly from point O, location of source is nothing but again A. Means equal distance but finite distance. What is the total? Total is nothing but 2A. So 2A is finite value which is not equal to 0. Okay, which is not equal to, supposed to 0. Always remember that means it's a finite value which is not equal to 0. 2A, that is the finite distance. Okay, it's a finite distance. It is not going to be 0, means it is not very close. All right, I have explained source strength is nothing but Q, and sink strength will also be Q. What is difference? Sink will be only minus and source will be only positive. This is the only difference. Magnitude wise it is same. Okay, always remember here I have mentioned 2A, that is the distance between the source and sink, which is the finite value. That should not be a 0, otherwise it will be different meaning. So for that reason I am saying again and again, 2a is a finite value which is not going to be 0. All right. Once this thing will be there, so once you superimpose this two different flow, source and sink we have separately. Now once you superimpose and both are at distance 2a, once you superimpose, then what will happen? From the origin it's at equal distance. So once I will superimpose, so the flow will be something like this. See the point, this is nothing but O. So this point is nothing but O. See carefully, it's very easy and you will understand easily. Source is what somewhere here and sink is what somewhere here, because both are at equal distance. A and A, from O it is A distance. This is source S1 and this is what sink S2. You remember in this way, S2. So I can say this is nothing but S2 and this is nothing but S1. All right. Now just superimpose this and you combine and then check what will be the effect and how the flow pattern will be, that you are going to check. Source is what generating the flow, and means from the source flow is what coming out, something like this, the flow is what coming out. Okay. And sink will be absorbing the flow, so flow will be coming something like this. Other, like, because I have shown you the source will be generating the flow, so it should be like this, it should be like this, it should be like this, should be like this, and multiple streamline. These are what? These are the streamline. I had explained in case of the source, this will be the streamline. Okay, potential line will be circle. I already have explained, please go through it. So this is the source, so all the streams line will be coming from the source. Now if you check the pattern, because this is the sink, what is the work of sink? Sink will absorb the flow. What is the work of source? Source will generate the flow. The flow is generating, but the sink at the same time it will be absorbing also, something like this. See, the flow is what absorbing by the sink. Similarly, source is generating the flow, but sink will be absorbing the flow, something like this. See? Okay. Right. If you see in this way, so basically what happening? If you check proper pattern, so it's just like a all streams line. Even though if you talk about this streamline also, so because this is the sink, so for the sink flow will be absorbed. For the sink flow will be absorbed. For the source flow will be generated, something like this. Flow will be generated, something like this. Okay, this flow will be generated something like this, and obviously sink will be absorbing the flow. See the pattern. So pattern will be something like this. Sink will be absorbing the flow, source will be generating the flow. Okay, so actually if you see one kind of the pattern you will get, and that pattern if you see here, I must say this pattern is something like this. See, in short here I can show you. If it is source and sink pair, so it will be like this. See, this one you can make S1, this one you can make X2, both are at finite distance. See, this total distance, this is the S1, S2, so this total distance is nothing but 2a. If you see the pattern in a small diagram I will draw, so it is like initially it will have a plot something like this. Something like this. Okay, many multiple streamlines you can draw, so obviously you will get pattern something like this. So source will generate the flow, sink will absorb the flow. That's all. That's I wanted to show you. And when it is happening, when there is the pair of source and sink, and always remember condition is there, it is apart from each other by distance of 2a, which is the finite distance, which is not going to be 0. So this is the pattern when the source and sink are both are uh, away from the origin with distance of AA. The total distance between source and sink will be 2a now. Okay. Now, if you check once the flow is what superimposing, so ultimate diagram of the superimposition you will get, it's like the big diagram if you draw, then it's just like a circle you will have, and circle will be forming something like this. If you concentrate, you may get it. How it will be forming? See, this will be the circle, and downside it will go something like this. Means center will be not origin, center will be somewhere here. Huh? Okay, one big diagram, I mean one single circle I will draw, then you will understand, because many streamlines are there, so because of that maybe confusion you may have. So one single circle I can draw here, easily you can understand. This is what S1 and this is what S2 with equal distance. If you see, so because source is what generating here flow, and sink is what absorbing the flow, something like this. If you combine this, so you may get exact circle, something like this. See, something like this. Where is the center? Center is what here. This is the one complete circle basically. You are good in drawing, then you can easily understand. Similarly, for downside also, because this is the source, so source will generate the flow and sink will absorb the flow. So it will be again circle, exact circle you may have. Okay, and here the center will be something here, somewhere here. Okay, so complete circle you will get there. It's very easy to understand. You can draw the pattern. Ultimately, whatever the circle you will get, so definitely you will write the equation also for the circle. Now, what will be the equation of the circle? That is our point of discussion. So directly I will write here. You can, because derivation is not important at all. You should aware like how the flow pattern, and suppose in problem they have given four uh, you know diagram they have given, and they said which one is the sink source sink pair. So easily you can recognize. For that reason I am showing the pattern and writing the equation also. Okay. So now for this particular condition, which is nothing but source sink pair, what you will have? Source sink pair. What is the equation of superimposed flow? Okay. What is the equation of superimposed flow? In terms of stream function. If you write the equation, see what you will get. X, because this coordinate is nothing but x and this is nothing but y. So it's a x square plus y a cot 2 pi psi by q. Okay. Y square is equal to a cosec 2 pi psi by q whole square. So it's a kind of equation which is nothing but x square plus y square is equal to a square. Yes or no? If you check, if you see the center which is moving along y direction, for that reason you are getting x square plus y, and this term you are getting in y. You got my point or not? Because your circle, if you see, it is moving in vertical direction. In vertical direction it is moving. So easily you can say, if you find the radius of the circle, any circle you can choose. I am just taking this one. So this radius, what is the radius? R. Radius will be R, and obviously center, this value of center, because here also you will have a center and here also you will have a center for the circle. So upper side center will be positive value and downside center will be negative value. Yes or no? So I can say for this particular diagram and for this particular equation, if I am interested to write the center will be x comma y. So x value definitely it will be 0, because see, I told you center is what moving along y direction only. If you see the particular diagram, you will understand here. So x will be 0 center, and y is nothing but, as I told you, upper side circle will be positive and downside it will be negative y value. So I can write plus minus a cot 2 pi psi by q. This is the center, okay, x and y value. And also you can see this, I told you this is the y plus something. So this is nothing but what? A cot 2 pi psi by q. Yes or no? For that reason, this a cot 2 pi psi by q you got here, that is the center now. If this term will be 0, then it will be what? X square plus y square is equal to a square. So if x square plus y square is equal to a square, then what will be the center? 0, 0. But here y, x is, there is no constant term, hence center for x becomes 0, but in y constant term you are getting, that means center is what? Moving in y direction. That's the reason this is plus minus a cot. If you are going for upper circle, it is plus a cot 2 pi psi by q. If you are writing center for the downside circle, this is the circle C2 and this is the circle C1. So for C2 it will be minus value, minus a cot 2 pi psi by q. This is the center. What is the radius? Radius is nothing but, check right side. This is what? A cosec 2 pi psi by q. So, and square obviously. So what is the radius? Our radius is nothing but r. We can write a cosec 2 pi psi by q. This is the radius. Rest, what is psi? Psi is nothing but a stream function, obviously. Psi is nothing but a stream function. Okay. A is what? Distance. Of source or maybe sink also, the same distance from origin. What is Q? Q is nothing but strength of source or sink, right? I hope this one is very clear. You may also think about the circle, why the center is not moving along x-axis. That also you can write. It's your choice. So that time your source and sink will be in vertical position. Like here, source and sink in what? In horizontal position, S1 and S2. If your source and sink is what? In vertical position on y-axis, then center will lie on x-axis also. How it may appear, I can show you. Separate one more diagram I can show, so it will be more clear to you. So source and sink pair I'm writing here, see. I'm saying source and sink is what? This is the source S1 and this is what sink S2, right? I'm saying here also, I can say here also we have a source, that is S3, and here also we have a sink S4. That also we can keep in this way. So, okay. So how the diagram will be? It's very easy. Roughly, I'm just going to draw. You can understand how the diagram will be. So for the horizontal source and sink, just now you had seen, it was something like this. This was the circle. Exactly, if you draw, then you will get circle. Wait, I'll try to correct. Otherwise, you may get confusion. You may later on you may think it's a oval shape. It's not a circle, but actually it's a circle. I can give S3 here and S4. Not here. Here S4. Right. So roughly, I'm just drawing there. You try to connect it. So for because of S1 and S2, the circle will be something like this. Because of the S1 and S2, circle will be something like this. Right? And downside circle will be something like this. It will be downside circle. For upper side circle, this is the C1. Downside it is, this is the C2. And what about source and sink, which is S3 and S4? So because of this also we'll have a circle, but it will be on horizontal axis. It may be like this. For this, if this is the source, so source and this S4 is what sink. So this is the one circle you will get. Similarly, this side also one circle you will get. Something like this. Source and this is what sink. So now see, here we have a center, you can say C3 and C4. So on x-axis also you can get circle, but your source and sink should be on y-axis. Okay. So easily, this is obviously it's not look like circle, but you can imagine because all points I have explained, so you can consider. Now I'll show you the diagram how it may. And something like this type of circle will come. Okay, this type of circle will come. Okay, so horizontal and vertical. Roughly I'm just drawing so you can connect it. Hope this one is more clear. This one. All right, anyway, now coming back to the theory of previous part. What was that? Source and sink pair is done, then we have to discuss doublet flow, right? So the special kind of the source and sink combination I have to show you. What is the special? That is nothing but doublet flow. Second one.
2a is equal to 0 होगा ना सर?
So in case of the doublet flow, it is source and sink combination only. Source and sink combination only. But a special condition is there. Okay. This 1 marks also they can ask in doublet flow. what are the flow, different flow. So obviously in doublet flow also we have a source and sink. Huh? Source and sink is there, and equal strength, okay, with equal strength, equal strength, equal strength will be there, but one special condition. What is a special condition? A special condition is that 2a distance approaches to 0. This is the special condition. Always remember, for single marks they can ask question, okay. So doublet flow is nothing but it's a combination of source and sink with equal strength, but both source and sink approaches, distance between source and sink, which is 2a, approaches to 0, okay, approaches to 0. One point. Second very important point, the product of 2a and strength. 2a is the distance between source and sink, and q is the strength of source and sink, known as doublet strength. Known as doublet strength. And now this doublet strength is now denoted by, it is denoted by now mu. It is denoted by mu. Again you try to understand. Earlier this was the source S1, this was the sink S2. This distance from the origin it was A, and this distance it was, both distance was 2a. This is the simple source and sink flow, which is equal distance from the origin, and that becomes distance 2a. Now if it is doublet, for this doublet, this 2a approaches to 0, means if it is approaching to 0, that what is the mean of it? So the meaning is very clear. Source and sink at the same point we have. Yes or no? Source and sink both are at the same point. That's the mean of 2a approaches to 0. So that time 2a distance into what is the strength of the source, that is q. If you write the product of 2a and q will give the doublet strength, just like a source strength was q. So now doublet flow have generated because of the special combination of source and sink. And now if you write what is the doublet strength, so it will be mu, but value will be 2aq. Always remember, this is very special here. This is very special. Okay. So the point is, if you write doublet strength, it is denoted by mu, and it is nothing but 2a. Always remember, a was the distance between 2a was the distance between source and sink earlier, but now it approaches to 0, means it becomes at same point. So 2aq now will be replaced by mu. Okay, this is one very important point you got. All right, now again derivation will be there, but here I told you derivation is not important. The important point we have to write for the doublet flow. Okay, what is the important point? First we have to write a stream function. A stream function for doublet flow. What is the stream function for doublet flow? Psi. It is nothing but minus q upon 2 pi. This is the one derivation, but formula you have to remember. 2a sin theta by r. Okay, 2a sin theta by r. What is the r? R is basically the distance. Okay, r is the basically distance between one particular point we have taken, that is some other place, one point we have taken, that is p. Okay, so that radial distance has been given. Okay, radial distance has been given, and obviously once it is required we can convert into Cartesian also. I'll show the diagram, it will be very easy for you to understand. So r is nothing but radial distance. I will show the diagram later on. Just first of all, just finish this formulation. So psi is nothing but 2aq. You are getting 2aq in numerator. So 2aq nothing but mu. So minus mu upon 2 pi sin theta by r. This formula itself is very important. Okay. Always remember mu is nothing but doublet strength. So if you check the diagram, source and sink, as I have mentioned, it's very, close to each other. It approaches to a distance is approaches to 0. So I can say this is what source S1 and this is what sink. Okay. So distance between source and sink is nothing but 2a. I can take x-axis here and this is the y-axis. It is x-axis here and it is y-axis here. Okay. So obviously y-axis means distance will be the y and this is distance x. So somewhere here I can consider one point and this distance is nothing but y vertical. This point P we have here. So the radial distance is nothing but r. This radial distance is nothing but r. Okay, r. And from the source, this radial distance r, small r, we have here. Okay, and it is nothing but from the sink S2, and theta also we have here, not clearly. Is also this distance will be theta. So what you are getting r, this is r now, and this theta you are getting here. So at least here you can understand like how that r and theta came into picture. Otherwise, that's the reason this diagram I have given. That is enough. We are not going into detail of the derivation because that is useless for you, because it's a competition only. So you should remember the formula, that's all. So this is the stream function. Okay. Similarly, we can write the equation of doublet flow in terms of stream function. So equation of doublet flow. Equation of doublet flow in terms of stream function. In terms of stream function, right? What will be the equation then? Very important. Okay, so equation will be x square plus y plus mu upon 4 pi psi. Okay, square is equal to mu upon 4 pi psi square. Again, if you see, this is what equation of circle. See, this is the equation of circle, and What is the center here? What is the center for this circle equation? What is the center? Again check x, it becomes 0. Y, it becomes mu upon 4 pi psi. This is nothing but center. What is radius? What is radius r? It's nothing but mu upon 4 pi psi. Okay. This is very, very important. I will show you how circle mathematically I am writing here, but don't worry, diagram I will show you. I will draw the pattern and I will explain the pattern. So this radius and center, because mathematical formula directly I am writing, because if we'll go for the derivation, it will take so much time and it is not useful for you because not required derivation. Mathematical model I am giving directly, but flow pattern I will, each and every points I will explain. So nothing to worry. Now if you see the equation of doublet flow in terms of stream function, you have written here, and center and radius you need to remember. Everything you are knowing now. Mu will be the doublet strength, psi will be the stream function, rest everything is what known. X, y is the obviously plane coordinates. No? Mu is the doublet strength, psi is the stream function. That's all. That is the only parameters available here. Now what is the flow pattern of doublet flow? Flow pattern of doublet flow. Flow pattern. What is the flow pattern of doublet flow? So see, now one thing I have told you in starting of the doublet flow, like doublet flow is the special case of source and sink. First point you have seen, a special case of source and sink. Now, what is the second point I had given here? It's a special case of the source and sink. Yes, special. And what is the condition? Condition was 2a, that was the distance between source and sink. Here, see, 2a. 2a should approaches to the 0. 2a should be 0. It approaches to 0 basically. It means both distance between source and sink, if it approaches to 0, means what is the mean of it? It means its mean is both are lying at the same point, meaning suppose this is the what source. So if this is the source, so from the source what will happen? Flow will go out. So flow is what going out like this, because this is the source. But at the same point we have again sink also. Again on the same point we have sink also, so flow will be absorbed something like this. This is the upper side. Similarly we'll do for the lower side also, because we have source on the same point. So flow will be generated like this. At the same point we have a sink also. Flow will be absorbed here. Yes or no? So this thing will be continuous, and I can now draw the multiple diagram. It like just like a 8, na? 8 number we are writing, na? 8 number. Sorry. Something like that. Eight shape, na? 8 shape. You have to remember for the doublet flow, shape will be 8. Easily you can remember in this way. Right. So this side it is source, hence flow will be generating in this way. And this side it is sink, flow is what absorbing in this way. Similarly here source and sink. So this is the flow pattern. And if you single diagram I will show here, then what you will get, see, because multiple streamlines if you see, then they may create confusion. But if single, if you check upper side, it may have something like this. This is the upper side. What is this? This is nothing but circle. Similarly, downside, if you check, downside also, this is the source and this is what? Sink. Simple. Source and sink. So this is what? Circle. Yes or no? Circle. Now the point is, these are what? These are streamlines or potential line. Remember, these are streamlines. So question can be asked, because here also now you got the circle, right? This is the circle actually, and already mathematical model I had given. This is the stream function. In terms of stream function, you have written equation of doublet. So you got this, obviously this equation you got, but if you compare with the circle equation, so it's clear now what is the center and radius. So basically this is the equation of circle, and you got the center and radius. If you check where is the center, again if you single diagram, see where is the center. This is the center, that is C1, this is C2. If I say, so the center, so center is nothing but from here to here, this is mu upon 4 pi psi. Check, 4 upon psi. And at the same time, because it is the radius also, because check, your circle is what? Touching to the origin. That's the reason it is radius also. For that reason, your y-axis, center and radius both are the same, because circle is what? Touching to the origin. Here if you check in this case, it will be very clear. Mathematically I'm not going to prove, I mean I'm not going to derive, because it's take so much time, but here you can understand. See, here the radius and center on y-axis, it is not same. Why? Because check the diagram. See, this circle is not passing through the origin. Origin is here, and circle is what? Passing just below to origin. And for the second downside circle also, it is passing here. I mean the circle is not passing through the origin. For that reason, radius and center is what? Different. But here in this case, check, your here, see, circle upper or lower, any circle you can check, it is passing through the origin. Hence center and radius both are same. If you go downside, so obviously this value will also be same, but it will be mu upon 4 pi psi with minus sign. I should write plus minus here na, kahan gaya ye, theek hai. All right, so again I must say, these are the streamlines. So I can say, in case of doublet flow, this is the note point. Note, in doublet flow, streamlines are circles. Circles to x-axis, circles, circles, and also you can elaborate, otherwise it's okay. Streamlines are circle, okay, and streamlines are circle, that is okay, but where is the tangent? See, streamlines are circle, but where is the tangent? Tangent on y-axis. So we can write here circles, tangent to x-axis, tangent to x-axis, okay. And where is the center? Center on y-axis, tangent to x-axis, center on y-axis. Simple. Huh? So just like here you have seen, on x-axis and y-axis both cases you have seen the circle, 4 circle. Similarly for the doublet, how 4 circle on x-axis, because source and sink you kept obviously on the same point, okay, on the same point, but another streamlines also you can show. So how the circle will appear? So this is the origin. Your circle will appear something like this. See, circle will appear something like this. this two circle. This is what is streamline. Hence you have to show the direction source, sink, source, sink. Doublet I'm showing, okay, doublet. But now the story is what not end up here. Suppose I'm interested about the potential function also. So just like here I had shown you the stream function for doublet directly I had written with this diagram. Derivation I had not done, but psi I have given to you. Similarly phi, that is the potential function. Similarly potential function we can write. Potential function for doublet flow. So as I told you, this is the derivation, but directly just like stream function I have given. Similarly, I will write the potential function phi also, and this formula you need to remember. It's nothing but just like a stream function, it was in terms of q upon 2 pi. Okay, it was given for the stream function. It was, if you remember, q upon 2 pi, 2a sine theta by r was there. But for the potential function, it will be just opposite. I mean, it's a derivation, but as I told you, no, derivation is not important at all there, and unnecessary we cannot waste our time. So potential function directly you need to remember q upon 2 pi will be same, just like a stream function. Only for the potential function cos component will come, and that will be a cos theta by r. In case of stream function, it will be a sine theta by r with minus sign. So q, okay, this was, I think stream function, it was 2a sine theta, na? Let me check. 2a sine theta, sorry, because distance 2a was there and you considered approaches to 0. So 2a cos theta here will have 2a q will be what? Mu upon 2 pi cos theta by r. This is nothing but potential function. Done. Okay. So this is the potential function for the doublet flow. What was the stream function? It was minus mu upon 2 pi sine theta by r. What is the potential function? Mu by 2 pi cos theta by r. Okay. Now, if you check what is the equation of doublet flow in terms of potential function. What is the equation of doublet flow in terms of potential function? So you can write here equation of doublet flow in terms of potential function. Standard equation you have to write x minus mu upon 4 pi phi square plus y square is equal to mu upon square. See, this is also equation of circle. Yes or no? So what is the, this is also equation of circle. Huh? So what is the center for this circle? Now see, center is nothing but, now y constant is 0, but x constant we got. What is the x constant? It's nothing but mu upon 4 pi phi. Okay. This is the x and y becomes 0. So this is the center, means center along x axis. And what is the radius? R is nothing but mu upon 4 pi phi. 4 pi phi. Okay. mu upon 4 pi phi. Right. Okay, so what is the pattern for this potential function? How you can draw the potential function? Obviously center should be on x-axis. So potential function directly you cannot draw because they do not have any direction. So first you will draw the stream function. For the streamline, for the doublet flow, where is the streamlines? It will be circle with center on y-axis and tangent to x-axis. This is the streamlines. Okay. But for the potential function, how to draw potential function now? So potential function will be perpendicular to the streamline. That obviously potential function means you are going to draw equipotential line. You have written equation in terms of potential function, but if you draw the lines, so for the potential function, equipotential line will come. And for the stream function equation, streamline will come. So what you have seen here, this is the streamlines. Now all are streamlines because you have written equation of doublet in terms of stream function. See, so for the stream function, streamlines will come. That's the reason I have written here streamlines. See, these all are streamlines. There should not be any doubt. Streamlines. But if you write equation of doublet in terms of potential function phi, then now this equation you have to draw the pattern, but that pattern will be equipotential line. So this is the streamline, but equipotential line if you want to draw, then it should be perpendicular to the streamline. So how it should be perpendicular? You can see. It will be just perpendicular, something like this. Meaning is here is 90 degree. Anywhere where they are cutting to each other, it's 90 degree. So this is the doublet, but I have shown both patterns. I mean, this is very important here and very interesting. These two are a streamline. These two are streamlines. Okay. And these two are equipotential line. Equipotential line. Similarly, multiple lines you can draw. Done.